question 5. So, I think the key bit with part A is to realise that if we throw this particle up to the top at B and then comes down again, the length of time it takes for the particle to get from A to B is the same as the time to get back from B to A. So given the time for the whole journey, A up and back down to here again is 3 4/7, the time to get from A to B is just half of this, which is 25/14. Well, it's then fairly straightforward. We know that our final speed is 0 at the top. Just before it comes back down again, the speed stops for an instant. So V equals 0. We've just worked out T to be 25/14. Our acceleration is fighting gravity, so that's minus g. So using the SUVAT V equals u plus at, we can now work out that u is 17.5 as required. Now for part B, find the greatest height above A reached by the stone. Well, as I described earlier, V is 0. We've just worked out u to be 17.5. A is still minus g. So using the SUVAT equation, v squared equals u squared plus 2as, we can work out that distance to be 15.625 meters. Now, find the length of time for which the stone is at least 6 3/5 meters above A. So really, what I'm going to do here, I'm going to just use the SUVAT equation, s equals ut plus half at squared. The distance that we're considering is 6 3/5, which is 6.6. Acceleration is fighting gravity, is minus g, and our initial speed, referring back to part A, is 17.5. Now what I'm doing here, when I use this, I get 2 times. I get the time it takes to on the way up to get to there, and then I also get the time on the way down when it's here. So obviously taking one from the other gives us what we require, which is the time when it's above 6 3/5. So substituting into the equation, we get a quadratic to solve. So just going back to GCSE terminology, A is 4.9, being the coefficient of t squared, B is minus 17.5, and C is 6.6. Just be careful, this A is not the acceleration, so perhaps I shouldn't have used A, but I'm just trying to familiarise yourself with your GCSE skill of using the quadratic formula. So substituting in, so t is minus b plus or minus the square root of b squared minus 4ac all over 2a. Substituting in, we get this, giving us the values for t of 3/7 and 22/7. As I said before, we need to take one from the other to find the time when it was above this height. It's 22/7 minus 3/7 is 19/7 seconds.